Now we are going to study the second important component the atom is made of, which is the electrons. So the electron carry the same amount of a charge as a proton carry, but with a different sign. So they carry the negative charge. So all the electrons are the same. You cannot distinguish who is the electron 1, who is electron 2, who is the father, who is the son. So they are all identical. And also they don't like each other because they carry the same sign of the charge. So they will repel each other based on the electric force. And because of that, the structure of the atoms is so empty due to this kind of repulsion that all the electrons try to separate away from each other. So most of the space, it is empty. So now you have some understanding about the protons and the electrons. Now the final and the third component the atom is made of is the neutrons. What is the neutrons? They are very similar to the protons. So the nucleus is made of the combination of the proton and the neutrons. So they have the same mass. So the mass are the same, but the neutrons do not have the charge. So from the word here, you can see it is neutral. Yeah? So they don't carry any charge, so they don't have the electric force in between. So now you know that the nucleus or the atoms is made of the protons, neutrons, and electrons. Now I'm going to define some word people at the very beginning may be confused, but it is just about definitions. The first one is the atomic number. What is the atomic number? It is just the number of the protons in each element. Okay? The atomic number is only the number of the protons. So now I'm going to introduce you the second one, third one, so don't try to confuse them. And also, the protons and the neutrons, sometimes in the literature, people will simply just call them the nucleons. So this is the particle made of the nucleus. So they are different particles, but when you say nucleons, they included the protons and neutrons. Now let's try to summarize the property we have studied. So in the chapter 8 and 9, you already have a basic sense of feeling that the mass of the protons, you can see here, is much heavier than the electrons. So this is the ratio between them. But now if you try to look at the true mass in terms of SI unit, you can see how tiny the mass of the electron it is. And the charge carried by the electrons is negative. And the charge carried by the proton is positive. And the charge carried by the neutron is 0. And now let's try to compare the mass between the protons and the neutrons. You can see they are almost the same, but the neutrons is slightly heavier than the protons. And the simple explanation is that due to the charge. Because the particle carries the charge, they will have smaller the mass. So you can see that the actual mass between the proton and neutron is so similar. And also the other reason why the nucleus is made of proton and neutron is that they don't have the charge. So they will not interact electrically with the protons. So they can make the atom stable. So this slide basically summarizes what we have learned so far. So now I'm going to define a concept so-called isotopes. What is the isotopes? They are the same atoms and they have the same number of the protons, but inside the nucleus, the number of the neutrons is different. So let me give you the examples. So hydrogens, on the periodic table, you will see that hydrogen is only made of 1 protons, 0 neutron. So there's no neutrons. But you can make up a particle called a hydrogen 2, which is at the nucleus, you have 1 proton and 1 neutron. This is so-called a deuterium. This is not a stable particles. And you can even make a particle, the hydrogen 3, which is made of 1 proton and 2 neutrons. And this is called a tritium. So they are all so-called hydrogens. And the difference between them is just the number of the neutrons. All other properties are the same. Only the mass is different. So this is the concept of isotope. So the same for the iron. Iron is a particle originally made of the 26 protons and 30 neutrons. But if you try to remove one neutron from the irons, it is the so-called iron 55. So they still share the same property, chemical property or physical properties, but the only difference is the mass. So that is how when we say about isotope, that is what we mean. The same number of the protons, but different number of the neutrons. Now, I'm going to define, beside the atomic number, I'm going to define a so-called mass numbers. So what is the mass number? The mass number is the total number of the protons and the neutrons in the nucleus. And the atomic number is just the number of the protons. So at the very beginning, people will confuse which one is which one. So it takes time. So just once you forget, I would say the best way is just check the textbook again about the definitions. So now, for the isotope I just introduced you, as I mentioned, the difference is only the mass, not the electric charge. And you'll find out electric charge will play a very crucial role in the chemical properties of the atoms. So which means actually there's almost no difference about the chemical properties. So the isotope is just, the only difference is the mass. So therefore the total number of the neutron in isotope is the mass number I just introduced you here minus the atomic number. So in the future, if I give you the mass number and atomic number and ask you to find out the number of the protons, neutrons, this is the way how you get it. So I already introduced you two different kind of number. So first is the atomic number here, and now it is a mass number. The third one, people will get more confused, is atomic mass. What is the atomic mass? It is the total mass of the atoms. So it is made of protons, neutrons, and electrons. Most of the time, electrons are so tiny compared with the proton and neutrons, so you can better say the mass from the proton and neutrons. But intrinsically, that just means that how heavy the atom it is. So for examples, in the periodical table, later on I will show you that they all will give you the so-called atomic mass in terms of atomic mass unit. And you will find out this atomic mass unit is related to the number of the protons and neutrons in combination. So this atomic unit mass, the unit here, is equivalent to 1.66 multiplied by 10 to negative 26 kilograms. So you can see that one atomic mass unit is very small in terms of SI unit. It is just the mass carried by the individual, the nucleons. So now let's have our second conceptual quiz. So the atomic number of element match the number of which one of the following? So if you remember, the atomic number is simply just the number of the protons. But for neutral atoms, the number of the protons is the same as the number of the electrons. So the answer is C. So this one is a little bit tricky. Most people probably will simply choose A. It is not wrong, but it is just partially correct. So now let's have another conceptual quiz. And this one will be the second unanswered conceptual quiz today. So if you know the answers, please email me your answers with a simple explanation for that. Now, the last topic. I will not have time to finish everything here, but let's try to start our discussion about the periodical table. So what is the periodical table? It is a listing of all the elements we know. All the elements. So the good news is that you don't have to remember the periodical table. So since now everyone is going to do the homework and the quiz and the exam at home, so just let you know where you can find out the periodical table. It is at the end of your physical copy of your textbook. There you will find out, in the appendix, you will find out the periodic table. So when you're doing the homework or the quiz or the exam, you are open to access to the periodic table there. You don't have to remember that. But in the following lecture, I will teach you that how to use the periodic table correctly. So that's the reason the main goal for this chapter is we are going to learn how to read the periodic table, how to get the information we want from that. Okay, so this is very important. It is just like a dictionary. When we need some information, we just go there and grab it. So now let me just give you a very general introduction to the periodic table. So you can see this is the one you're going to see at the end of your textbook. So here it is a list of all the elements we know. So there are many different kind of properties you need to know from these tables. So the first one, hydrogen, is the simplest and the lightest atoms in the periodic table. And you'll find out in the periodic table, they have many different kind of application in our daily life. So for example, the silver is made of the Ag atoms. So for example, the carbons, a lot of things in our daily life is made of carbon. Even the diamond is made of carbon. But it is just different kind of structure of the carbon. So for example, the wood, when you try to burn the wood, it becomes the carbon. So these structures is different from the diamond. So depending on the structures, the diamond is much stronger and hard material. That's the reason the price is valuable. But this is the third kind of illusion you will have. Actually, the price for the diamond is also given by the human being. So in fact, in the laboratory now, human being can manufacture or produce synthesize the diamond. Ideally, there's no way you can distinguish that. But for sure, the one you produce in the laboratory, it is much purer in the natures. They probably was mixed with some other element. But actually, the price for the diamond is not actually that. How I say, I'm trying to emphasize is that in the physics, we are going to study the world in different kind of language. So we care about our weight, about the color, and all other things. But you will see all the things in terms of physical world. They are simply in terms of just one kind of the illusion, or it is. If we shall consider the human being, actually, everything is neutral. No one is more important than the other one. This is the thing I'm trying to emphasize. So there are a lot of interesting property about the periodic table. So we will discuss with further details in our next lectures on Monday. So hope you all have a good weekend